This is Dr. John Bergduff. In this video, we're going to look at odds. Now, the word odds is used sort of casually among people almost interchangeably with the word probability. People will say things like, what are the odds that would happen? And often what they mean by that is, what is the probability? Odds and probability definitely are concepts that are related to each other, but they are different. And in this video, I want to show you how they are different and particularly how you calculate odds. You've probably heard the term odds in terms of horse racing, where you go to the track and they talk about the odds on the horse. So towards the end of the video, we'll explore exactly how this connects in with horse racing and other forms of betting. So let's get started. So I want to start by looking at the definition of odds. And you'll see that it is related to probability. Let P of A be the probability that an event A occurs. And let P of A with the bar over it, which we're going to read as A complement. Write that down over here. A with the bar over it, we're going to read as A complement, be the probability that the event A does not occur. So actually, if you just think in terms of the probability A occurs and the probability that the event doesn't occur, that's what you need. There are actually two kinds of odds. It's not just one thing. There are odds in favor, and the odds in favor of event are the probability of A over the probability of the complement of A, or the probability that A occurs over the probability that it doesn't occur. That probability of a complement can also be calculated by taking 1 minus the probability of A. And you're going to find out in just a few minutes that this, although this is the formal definition, it is in fact way more formal than we really need to be able to calculate odds. Now there's also odds against. And the odds against an event occurring are actually just the same fraction, take its reciprocal. It's the probability of A complement, or the probability that A does not occur, over the probability that the event does occur. Again, probability of A complement is 1 minus the probability of A. Now we will see in a minute, we'll do this calculation, and then I'm going to have a much friendlier way to describe the odds that I think you'll like. But let's go from the definition to begin with. So, for an example, if a single die is rolled, and remember die is the singular of the word dice, what are the odds in favor of rolling a number less than 3? So what you have to do is you have to decide, what is my event? The outcomes that I am interested in. What I want to happen is to roll a number less than 3. And I'm going to assume that we've already talked about probability in some sense or another. And we know that the probability of an event, just talking probability, is the number of outcomes you're interested in. Number of outcomes you want, let's say, to say words here, over the total number of all possible outcomes. So if you think about rolling a die, there are 6 outcomes possible. That would be 1, 2, 3, 4, 5, and 6. So that would be our denominator. And our numerator would be the number of outcomes that meet the description we have, that we want to roll a number less than 3. That means we would roll a 1 or a 2, and there are 2 such outcomes. So the probability of rolling a number less than 3, the probability of A, is 2 over 6. Now, ordinarily I would reduce that fraction, but for reasons that you'll see later, I don't want to do that right now. We'll come back to it though. Now, to calculate odds in favor, we're also going to have to calculate the probability of the complement of the event. Let's talk about that. Probability of A complement. Now, very simply stated, if the event A is rolling a number less than 3. A complement is rolling a number not less than 3. I'll say that all carefully here. So what would that probability be? Well, we'd have to think about how many outcomes are not less than 3. So that would include 3 itself. 3 is not less than 3. 3, 4, 5, 6. There's 4 such outcomes out of the 6 possible outcomes that you would get when you roll a die. So you have the probability that you do roll a number less than 3 and a probability that you don't. The odds in favor, now since we've called this A, let's say the odds in favor of A are the probability of A over the probability of the complement of A. And that would be the probability of A, if you look back a screen, was 2 over 6 over, so that's 2/6, that's probability of A, over 4/6. So a fraction over a fraction. And right now you're probably beginning to think, oh my God, this is getting really messy. I see fractions inside of fractions. But remember that the fraction bar, or a fraction bar, can represent division. So if you think of this more as 2/6 divided by 4/6, and then that's not so bad, because when you divide fractions, you take the first fraction and you multiply by the reciprocal of the second. Notice that the 6's divide out, and you simply get 2 over 4. Now, I want to put a special asterisk next to that because I want to come back to that. But we will go ahead and we'll reduce that fraction. So 2 over 4 reduces to 1 over 2. And here's an interesting thing. When we talk about odds, we use an old-fashioned notation for fractions that we don't use very much at all. Instead of leaving the odds as 1/2, we write it in this old-timey way where you say the numerator and then a colon and a 2. So the first number is the numerator, the second number is the denominator, and you read that as not 1/2, but as 1 to 2. That's just an old-fashioned way of doing things. Now, that all sounded really, really complicated, so I want to make it easier if we at all can. I want to look at the number where I had the asterisk, 2 over 4. And I want to think about where that came from and what the 2 and the 4 represent. The 2 came from the numerator of the probability of A. If you can see that right there. And if you think about it, what that simply is the number of possible rolls that are less than 3. In other words, those are the rolls you want. The 4, which comes from the complement up here, is the number of rolls not less than 3. The outcomes you don't want. That is going to inspire for us really a far more simple way of looking at odds. That the odds in favor of an event are basically the number of outcomes that you do want divided by the number of outcomes that you don't want. Now that actually is dependent on having all the outcomes in the sample space equally likely. So that's very, very important. And the casual, comfortable way of describing calculating odds when all outcomes are equally likely is to say simply that if all the outcomes in a sample space are equally likely, and an event consists of a set of outcomes that you consider, let's say, favorable, then the odds in favor of the event is the number of favorable outcomes over the number of unfavorable outcomes. Let me back that up one more. The favorable outcomes in the example we just did was rolling a number less than 3. That's what we wanted, the odds in favor of that we considered favorable. Unfavorable was rolling a number not less than 3. So the answer that I got can simply be stated as the number of favorable outcomes over the number of unfavorable outcomes. Now, we haven't talked about odds against yet, but if I go way back to the original screen, notice that the odds in favor and the odds against are simply just reciprocals of each other. You take the odds in favor and you flip it over and you've got odds against. So in that point of view, if odds in favor is number of favorable outcomes over number of unfavorable outcomes, the odds against is exactly the reciprocal, number of unfavorable outcomes over number of favorable outcomes. Let's explore that and try to make it as simple as possible. So you draw a single card from a 52 card deck. We're going to assume that drawing any one of those cards is equally likely. What are the odds in favor of and the odds against picking an ace? Let's start with the odds in favor of an ace. And I want to look at the top definition here, that one right there. Let's think of that as simply the number of favorable outcomes over the number of unfavorable outcomes. Favorable outcome here would be getting an ace. So the number of favorable outcomes is simply the number of aces. If you think about a deck of cards, there's the ace of spades, clubs, diamonds, and hearts. So that's 4 of them. There are 4 aces. So there are 4 favorable outcomes. How many unfavorable outcomes are there? Well, an unfavorable outcome would be picking something that isn't an ace. Now, we don't have that directly, but we know this. There are 52 cards in the deck. 4 of them are ace, and those are that's what we consider favorable. All the rest would be unfavorable. So in our case, that'd be 48. 4 over 48. The odds in favor of an ace are 4 over 48. Now, what you will do, you'll always get a fraction, but what you'll do first is you'll reduce that fraction. 4 divides into both the numerator and the denominator. 1 over 12. And then you write that in this very special notation, and we say 1 to 12. So that's how you calculate the odds more casually. But let me make that even more casual, because when I write the odds like that, what I'm really saying is basically for every 1 ace, there are 12 non-aces, let's say, cards that aren't aces. That's a way you could interpret what those odds in favor mean. For every 1 ace, there's 12 non-aces. If you think about in each suit, there's an ace and then there's 12 other cards. Same is true for all 4 suits. For every ace in the deck, there are 12 non-aces. That's kind of what the odds are saying. Hang on to that, because I want to build on that when I talk about odds against, and then when I also kind of go backwards. Let's talk about the odds against an ace. So that would be the number of unfavorable outcomes. So if you think about, if you want an ace, what would be unfavorable? Picking anything else. There are 48 unfavorable outcomes and 4 favorable outcomes. So that's building very much on just that informal definition there. 48 over 4. Now 48 over 4, 4 goes into 48 exactly, and you get a 12. But you really want to think of that as 12 to 1 if you're going to write it in this ratio format. The odds against an ace would be 12 to 1. And if you look at that, well, that's exactly the same as odds in favor. You just reverse the first and second numbers. And that says that for every 12 non-aces, things you don't want, there is 1 ace. I hope that helps make the idea of calculating odds simpler, and it's going to be incredibly helpful when we try to go the other way. Because what if I give you an example where I'm giving you the odds and asking you to go backwards and figure out the probability? From the definitions, that's pretty hard. From this sort of casual approach, it's not hard at all. So let's talk about horse racing, and this will be our final example. When you're talking about horse racing, the odds, when they talk about the odds on a horse mean the odds against the horse winning. So I've rewritten here the casual definition of odds against, the number of unfavorable events over the number of favorable events. The odds on the horse Flaming Banshee are 2 to 7. That's how I'd read that, 2 to 7. What is the probability Flaming Banshee will win? First of all, let's take the odds written in this ratio form and write it as a more traditional fraction. So the fraction would be 2 over 7. 2 over 7 is the number of unfavorable outcomes over the number of favorable outcomes. What would be favorable and unfavorable if you're running a horse race? Well, I think the favorable would be to win. So we'll start on the bottom here, and that would say that 7 is a number of wins. Favorable outcome is winning. Unfavorable outcomes is losing, so that would be the number of losses. So if I state this incredibly casually, what I'm saying is basically for every 2 losses, Flaming Banshee, I'm going to abbreviate, sorry, has 7 wins. Now let's make this super casual. The question is, what is the probability that Flaming Banshee will win? Well, if for every 2 losses, Flaming Banshee has 7 wins, how many races does that mean altogether? 9. 2 losses, 7 wins, 9 total races. Flaming Banshee, we believe, would win 7 of them, so the probability of Flaming Banshee winning, the probability of winning, would be the 7 wins over the 9 total races. So that takes me from odds to probability. Holding on to this idea that the odds against are the number of unfavorable outcomes over the number of favorable outcomes will get you to probability when you think about, okay, well, what does that mean the total number of outcomes is? And odds in favor would work about the same way. So I hope that gives you a sense of what odds are that you can practice. And if you go to the horse race track, I hope this helps there too.